Akansha P.S. Vishwakarma, Assistant Professor at Index Institute of Pharmacy, Malvanchal University, Indore, Madhya Pradesh. Primary and secondary metabolite. Primary metabolite, widely distribution in nature, partially in all organisms. Second, directly involved in growth, development, and reproduction. Third, they are not poisonous. Fourth, example carbohydrate, lipids, proteins, and amino acid. Now, secondary metabolite. Biosynthesized derived from primary metabolites, more limited, distributed in taxonomic plant. Second, for an example, reserpine from Rauwolfia serpentinii. Second, they do not directly involve in the normal growth, development, and reproduction. Third, some of these compounds are poisonous. Fourth, example alkaloids, glycosides, tannins, volatile oil, resins, and resins combination. Alkaloids, coined by V. Michener, German pharmacist in 1819. The term derived from the word alkali like. So they have some characters similar to naturally occurring complex amines. Definition of alkaloids. Alkaloids are the organic product of plant origin, basic in nature and contain one or more nitrogenous atoms, normally of heterocyclic in nature, and have marked physiological action when administered internally. General properties of the alkaloids. Physical properties. It is colorless, crystalline, solid, and possesses a sharp melting point. Some alkaloids like nicotine and quinine are liquid and volatile in nature. Some alkaloids are colored like berberine is yellow and benanidine is red. Solubility. Free alkaloids bases are fairly soluble in oxygen, sulfur, and nonpolar solvents and lower alcohol and partially insoluble or sparingly soluble in water. Salt, salt alkaloids are freely soluble in water and less soluble in alcohol and very sparingly soluble in organic solvent. Now, chemical properties. The normal elements present in the alkaloids are carbon, hydrogen, and oxygen. But every alkaloid should essentially contain at least one nitrogen in parts for basic properties. Chemical test Meyer's reagent potassium mercuric iodide solution give cream colored precipitate. Wagner reagent potassium triiodide solution gives reddish brown precipitates. Dragnodrov's reagent potassium bismuth iodide solution gives reddish brown precipitate or orange red precipitate. Now, classification of alkaloids. First, biosynthetic classification. Second, pharmacological classification. Third, taxonomic classification. Fourth, chemical classification. First, biosynthetic classification. Given to the precursor from which the alkaloids are produced in plant biosynthetically. So, all the alkaloids derived from the same precursor can be brought under same group even they have different taxonomic distribution and pharmacological activity. For an example, piperidine alkaloids derived from lysine, pyrrolidine alkaloids derived from ornithine, and indole derived from tryptophan. Pharmacological classification. Second, classification depend upon pharmacological action. For an example, CNS stimulant or depression and anti-malarias, etc. Individual alkaloids may exhibit different action within the same drug. For an example, in cinchona, quinine is an malarial, whereas quinidine is a cardiac depressant. In opium, morphine is narcotic analgesic, whereas codeine is antitussive. Now, third, taxonomic classification. Classification deals with the taxon, like genus, subgenus, species, and subspecies, etc. Large number of alkaloids are classified on their like various family like herbaceous alkaloids and siliceous alkaloids. Some Some phytochemists have stepped further and classified alkaloids based on chemotaxonomic classification. Fourth, chemical classification. Widely accepted classification of alkaloids. The basic of classification is the ring structure. Normally, heterocyclic ring present in the alkaloids divided into two categories. First, non-heterocyclic or proto-alkaloids, and second, heterocyclic or typical alkaloids. Alkaloids. Large number of alkaloids which possess heterocyclic ring structure are mentioned below. Take an example. Pyrrolidine, pyrrolidine for example, hygrine and stachygrine. Second, pyridine, example, resinine, ercoline. Third, piperidine, example, lubeline and conine. Fourth, trophin, example, atropine and quasine. Fifth, quinoline, example, cinchonine, quinine and quinidine. Sixth, isoquinoline, example, pipervarine, morphine, amantine. General methods of extraction and isolation of alkaloids. Method first, drug powdered, then moisten with H2O and treat with lime, then extract with organic solvent, petroleum spirit or ether, then filtrate. Next, add water, separate organic layer, then shaken with aqueous acid, allow to separate, then reject the organic layer, then aqueous layer contains the alkaloid soils. Method second, drug powder, then moisten with H2O and treat with acid, then extracted with alcohol or water, filtrate. Add acetone, then reject the organic layer, contain several impurities, then aqueous layer contain alkaloids, treat with ammonia or sodium bicarbonate. Add organic solvent, then reject the aqueous layer, then organic layer contain alkaloid. Now, functions of alkaloids in plant. First, they may have vital role in growth regulatory factor. Second, the alkaloids are poisonous in nature, thus they protect the plant grazing animal or insect. Third, they act as a reserve substance in plant and supply nitrogen or other element. Fourth, they might be the byproduct of various deoxification reaction in plant, and by this way they cause the formation of harmful substance in plant. Fifth, they are present in association with plant acid like cunic acid, cinchotanic acid, etc. Hence, they may provide the means of storing or transportation of such acids. Now, glycosides. Definition of glycosides. The organic compound, mainly of plant origin and rarely of plant which were on enzymatic or acid hydrolysis yield one or more sugar, moieties, glycone, and non-sugar moieties, al- aglycone or janine. The sugar glycone present in glycosides are monosaccharides like glucose, rhamnose, and rarely deoxysugars such saccharose found in cardiac glycosides. The aglycone part may be alcohol, phenol, or amines. The linkage between glycone and other and alicone is known as glycosidic linkage. Properties: it is colorless, but some them are colored like flavonoids are yellow and anthracene glycosides are red. They are crystalline or amorphous solid compound. Glycosides are optically active and normally LIVO form is more active, soluble in water and alcohol but insoluble in chloroform and ether. Glycosides can be hydrolyzed by mineral acid, water, and enzyme. Isolation Stats Auto method. Powder crude drug, extract with alcohol and filter it. Residue and filtrate. Filtrate tannins plus impurity plus glycosides. At lead acetate solution, excess of lead acetate is precipitated by passing hydrogen sulfide gas. Filter it. Tannin and impurity filtrate. Fractional crystallization, friction, solubility, chromatography, pure glycoside. Classification on the basis of the type of sugar or the glycone part. For an example, glycoside with glucose, fructosides with fructose, and pentosides with pentose, etc. Glycosides are classified on the basis of the pharmacological action exhibited by them. For an example, fugitive glycosides, allo, scanner, cardiac glycosides, digitals, T beta, diuretics, gochro. Glycosides are also classified on the basis of linkage between glycone and aligone part. Oglycosides. In these glycosides, sugar is connected to OH or phenol group. OH plus HO C3H1 1O5 gives OC6H1 H11O5 plus H2O. For example, rhubarb and senna, etc. C glycosides. In this type of glycoside, sugar is connected to carbon atom CH plus HO bond C6H11O5 gives us C bond C6H11O5 plus H2O. Example aloe and cascara. As glycosides, in this type of glycosides, sugar is connected to sulfur of SH group. SH plus HO bond C6H11O5 gives us S bond C6H11O5 plus H2O. Example, Sigrine from black mustard. And glycosides. In this type of glycoside, sugar is connected to nitrogen of NH group. NH plus HO C6H11O5 gives us NC6H11O5 plus H2O. Example, nucleosides. For glycosides classified on the basis of chemical nature, first, anthracene glycoside, second, saponin glycoside, third, cardiac glycoside, fourth, cyanogenetic glycoside, fifth, isothiocyanate glycoside, sixth, fumarate glycoside, seventh, aldehyde glycoside, eighth, steroidal glycoside, ninth, phenol glycoside, tenth, phenolate glycoside, 11 beta and miscellaneous glycosides. Now, tannins. Tannins are polyphenolic substances found in many plants, product of secondary metabolites. Secondary metabolites, as the name indicates, they possess the property of tan. For example, to convert hide and skin into leather. Detect by qualitatively by tannin test, the Goldbeater skin test, present in cell, sap and vacuoles. They act as astringent. They have capacity to combine with protein and precipitate them. Tannins definition: the complex organic non-nitrogenous phenolic substance of high molecular weight. They are used as antiseptics and in gastrointestinal diseases like diarrhea. They are also used in leather industries. Properties of tannins. Tannins are soluble in water, alcohol, dilute alkalis, glycerin, and acetone, but insoluble in organic solvent such as benzene, ether, and chloroform. They should possess tanning properties. Tannins with ferric salt gives blue, violet, or green color. They have precipitate with alkaloids and have heavy metals, therefore they are used as antidotes in alkaloid and heavy metal poisoning. In aqueous solution, tannin produce acidic reaction and have astringent taste. Classification. Classification based on chemical nature. Hydrolyzable tannins, and second is condensed tannins. Hydrolyzable tannins. These tannins are hydrolyzed by acids or enzymes and produce gallic acid or ellagic acid. Chemically, they are esters of sugar, usually glucose with one or more trihydrobenzene carboxylic acid. With ferric chloride, they produce the blue color, hence they are used in manufactured in ink. Examples: gallotannin from rhubarb, chestnut, nutagol, and clove, and elaginettannin from myrobalan of oak. Second, condensed tannin. They are also called as phosphobeta-tannins or proanthocyanidins. They are related of flavonoids pigment and have the polymeric formula flavin, thiol. On the treatment with acid or enzymes, these tannins are decomposed into red insoluble compounds called as phlobohans. With ferric chloride, they produce green color. On heating, these tannins produce catechol. Therefore, they are also called as catechol tannins. The drugs which contain condensed tannins are cinnamon bark, pale and black cacao, Coca-Cola seeds, etc. Pseudotannins. Pseudotannins are low molecular weight product compound and do not respond to Goldbeater skin test. Example of pseudotannins are catechin from cocaine and chlorogenic acid from Nuxomania and coffee. Extraction and isolation of tannins. The various type of the method of extraction depend the source of tannins are employed. As the tannins are high molecular weight compounds, so it becomes difficult to isolate the tannins in pure form. Thus the solvent used are mixture of polar, non-polar and semipolar solvent like alcohol, ether, water, acetone, etc. Identification test. Goldbeater skin test. The Goldbeater skin membrane prepared from the intestine of ox is soaked with HCl. Then it is rinsed with distilled water and is added to the tannin solution sample for 5 minutes. It is washed with distilled water and transferred to 1% ferrous sulfate solution. A brown black color on the skin confirms the presence of tannins. Phenazone test. 10 ml of aqueous extract of tannin is prepared and 1 gram of sodium acid phosphate is added. Warm it, cool and filter it. To the filtrate, 2% phenazone solution is added. All the tannins present are precipitate. Gelatin test. To the solution of tannins, add 1% gelatin solution containing 10% sodium chloride. The precipitate obtained confirm the presence of tannin. Test with ferric chloride solution. To the solution of tannins, add ferric chloride solution. A blue, black, violet or green precipitate or color confirm the presence of tannin. Matchstick test. Dip a matchstick in plant extract and dry it. Moisten it with concentrated HCl and warm near the flame. The wood of matchstick turn to pink or red in color, which confirm the presence of tannin. On heating, tannin with concentrated HCl produce fluoroglucinol. Further, fluoroglucinol react with the lining of wood and produce pink color. Thank you.